Let's add some more binary numbers, but before we do such, let's get our reference back up here. I'm going to only put two binary digits up here, and pretend we're driving on our scooter again. So this is 0, and this is 1, and then this will wrap to a 0 again, bumping his neighbor, and then we'll drive a little bit further, and there we go. So the decimal equivalents here is 0, 1, 2, 3. Right? And I just want to keep that up there for reference as we do our binary addition. All right, let's do binary number 1, 0, 1, 1, 1, 0, 0, and then for the bottom, let's do 0, 1, 0, 1, 1, 1, 0. Okay, let's add. 0 plus 0 is 0. 0 plus 1 is 1. And here we go. 1 plus 1, that's 2. And again, that's going to give us this extra digit out here, which we don't want. If we add 0 and 0 like we did here, that gives us 0. And so we're good with just one digit. I can represent 0 with just one digit. If I add 0 and 1, that gives us a 1, which I can represent in one digit. But all of a sudden now I have this significant digit here with a 2. I can't just go here and erase this 0 here, because now that's a 1, that's not a 2. The presence of that 0 there is important. Okay, so these are significant digits, but the most significant digit is this digit out here, the largest one. Anyway, I can't come down here and write 1, 0. We've already seen that's illegal. That's going to add more digits and make our resulting number much bigger than what it should be, simply because we're adding digits. When you add digits, that's bad. So how are we going to do this? Well, 1 plus 1 is 2. So if you look at this number here, we can say, well, I'll put a 0 here and we'll make change. I'll give you 1 up in here in this next category. It's the same thing as when we split that 17 up in the previous video. We're going to give you a 0 and we'll give you a 1. Now look at this situation. 1 plus 1 plus 1. Well, that's 3 ones, which is 3 decimal here, but then now I have 1 1 right here. 1 1. 1 1. 1 1. No, it's 1 1. Anyway, again, I can't just write 1 1 there. I have to do the same thing here. We know we can make change for powers of 2, so I'm going to say, okay, you keep one of your 1s, but then I'll give you another 2 up here. I'm going to move up 1 slot here. I'll give you another 2. So thus I just carried that second digit here. So this one, this least significant one, went down here. All right, that's kind of like the 7 did in our previous example. And then this one is going to move up to the next significance of digit, if you would. All right, and then we just move on here. 1 plus 1 is 0. Again, I have to carry the 1. So that's a 2. See 1, 0 here. 1, 0 here. 1 plus 1 is 0. Carry the 1. 1 plus 1 is 0. Carry the 1. And then 1 plus nothing is 1. Okay, I hope that's helpful and somewhat straightforward. I think, adding decimals is kind of difficult because now I have to think of 10 numbers, 0 through 9. But adding binary, I just have to think of 0 through 1. So anyway, it'd be good for you to take some time and come up with some binary addition examples and go through it. I'm going to give you one of my own. And let's see if I can. I want to keep this up here for our reference. I'll give you one, let you work it out, and then I'll work it out with you. Okay, here we go. 1 0 0 1 1 0 1 1 plus 0 1 0 1 1 0 1 0. Okay, write this down on paper, pause the video, work it out, and show me the result. I'll wait. Okay, no, I won't. I'll actually work it out. But pause the video, work it out. Okay. 1 plus 0 is 1. 1 plus 1 is 2. Again, so 0, 1. 1 plus 0 is 0, 0. That is 1. 1 plus 1 is 2, again, so 0, carry the 1. 1 plus 1 plus 1, that's 3 1s right there. There's a 3, so now I have to do 1, carry the 1. Okay, notice with the 2 we said 0, carry the 1. Now with 3 we say 1, carry the 1. And then 1 plus 0 plus 0, that's 1. And then this is 1, and this is 1. Alright, so pretty straightforward, I think, simple example. Now, let's verify that we have the correct result. And what's one way we could do that? Well, we could pull out the Windows calculator, which we'll do in a minute. But before we do that, I like to verify the result using base 10. So here's the exercise that we can do. Let's go back to red. Convert this number to base 10 and write its base 10 value out to the right here. And then convert this value to base 10 and write its base 10 value out to the right here. And then convert this value to base 10 and write its base 10 value out here. What we should see is a base 10 number plus a base 10 number will equal another base 10 number or decimal number. So pause the video and now work that out on your own paper and then come back. Okay, I'm actually going to do it myself as well. Let's go, first of all, I'm going to remove all these carries here. Maybe I should leave them, I don't know. But and then let's write the powers of 2 up here again. This is 1, 2, 4, 8, 16, 32, 60, not a good 60, 64, 128. Alright, so what's this first value in base 10? Well, it's going to be 128 here. See, there's 128. There's 0 64s, there's 0 32s, there's 116. So let's put the 16 right here. There is 1 8, 0 4s, 1 2, and 1 1. So what does that come out to be? That's 8 plus 6. Or let's see, there's 16 plus 6 is 22, 23, 24, 25. So I can't write 25 down here. I have to carry the 2. So I make change. I turn in some of my 1s, and I get 2 $10 bills out of it. 2 plus 2 is 4, plus 1 is 5. And then 1 plus nothing is 1. So this top number is 155. Notice it's an odd number. You can always tell an odd number from an even number by the presence of this first digit out here. This is the digit that determines whether we have a 1 in our value or not. And if we add 1 to anything, if we ever have a 1, then that makes our value odd. Anyway, side note there. Okay, let's do the same thing with this value, this bottom value here. Let's erase our work there, and it's again the same logic. So we have 0 128s, we have 1 64. We have 0 32s, we have 1 16, we have 1 8, and 0 4s, 1 2, and no 1s there. So let's see, 6 plus 4 is 10, 18, 20, and then 6, 7, 8, 9, that's 90. So we have 155 plus 90. Well, let's just work that out here. Let's say 5 plus 0 is 5. 5 plus 9. We're going to have to make change again. 5 plus 9 is 14. So that gives us 245. I'm going to write the 245 out here to the right. And then let's just erase that and erase that. Now, if we convert this value, this binary value to decimal, and the addition that I've taught you is correct, we should get 245 when we convert this value to decimal. Right? We can already tell it's going to be odd because of the presence of this 1. All these other numbers are even because they're powers of 2, and adding even numbers to even numbers always yields an even number. But the presence of this 1 out here will yield an odd number. So anyway, let's convert this value now down here to its base 10 or decimal equivalent, using the same trick we used for the 2 values above it, this value and this value. All right. We have 0 128s. We have 1. Oh wait, sorry. We have 1 128. 128. We have 1 64. We have 1 32. We have 1 16. 0 8s, 1 4. Wow, we have a lot of numbers, don't we? 0 2s and 1 1. Okay, so let's add this up. 6 plus 4 is 10. 8 plus 2 is another 10. So that's 25. Okay, write it here. Carry the 2, making change. 2 plus 2 plus 6, that's 10. 13, 14. So there's a 4. And we have a carry there because that's 14. 14. Or I guess 14. and then 1 plus 1 is 2. That's 245, which is the same as this number here, 245. Very good. So I think it's real simple to come up with some basic binary numbers. Just come up with some random sequences of zeros and ones and add them up and convert them to decimal and do the same addition over here. And it's good exercise. And now you're starting to think in binary, and that's pretty much adding binary numbers.